going to start Unit 1 with some inductive reasoning. Inductive reasoning is the use of patterns to make a prediction, and we're going to call that prediction a conjecture. A counterexample will be a specific case to prove a conjecture false. We'll do more of that stuff tomorrow. So what I would encourage you to do as I go through numbers 1, 2, 3, and 4 is to pause the video for just a minute and then come back and listen to me go through the patterns. So if you want to do that, go ahead and pause now. Come back after you feel like you've got these settled in. So here we have our perfect squares. This is 1 over 1 squared, 2 squared, 3 squared, and so on and so forth. So this is 1 over 7 squared, 1 over 8 squared, 1 over 9 squared, and 1 over 10 squared. Here we have cubes. So this is 1 cubed, 2, 3, 4 will be 1 over 64, 5 will be 1 over 125, and 6 will be 1 over 216. This next one tends to be one that people kind of chuckle over after you see what the pattern actually is. These are the first letters of our numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Patterns can also be used in solving a variety of different problems. Look at how our pattern is used in solving for the last digit of 2 to the 81st power. So you guys know how our exponents work. This is a gigantic number. And just to kind of put it into something that you can visualize, if you plug in 2 to the 81st power in your calculator, you get an answer of 2.41785, blah, 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 and then you have this little e, which is that times 10 for scientific notation, to the 24th. So this number has 25 digits in it, okay? And what we're looking for is, after all these digits, what's the ones place? And our calculator is not going to tell that to us, but a pattern will. So as we look through these, I'm going to kind of go through a set of steps. It's going to be confusing at first, and we're going to work more examples here, and then we'll work more examples in class as well. So the first thing that we've got to do is find your pattern. And in this case, it's laid out for you. So 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16, 2 to the fifth is 32. You'll notice that this 2 in the ones digit comes back around to us. So what that tells us is that this piece here repeats. 2, 4, 8, 6. All of that keeps going. 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6. Again and again and again. So our question is number 2, how many pieces are in the pattern? And in this case, there are 4. And step 3, how many times will that pattern repeat? Okay, so we're going to take this here. I'm going to erase what I had up here above so we've got some more room to write. And I'm going to go back in with a different color and answer these questions. So we're going to find our pattern. It's 2, 4, 8, 6, again and again and again and again. How many pieces are in that pattern? There are 4. How many times will that pattern repeat? This is where we're going to start using this 81. So what we're going to do for step number 3 is we're going to take our exponent and we're going to divide it by that number of pieces in the pattern. And in this case, that is going to be 81 divided by 4. So imagine you've got 81 people in line, and you have got all these cards, and they just repeat 2486, 2486, 2486, 2486. So what's going to happen is this number of cards, 2486, is going to get passed out perfectly, and then there might be some extras to hand out, and that's what we're trying to figure out, is what is that last person in that line going to get? So this repeating pattern of 4 will go into 80, 20 times perfectly, 81, giving me 80. And don't put this back as 1/4, we're going to go old school here and write it as remainder 1. So what this means is that we're going to go through 2486 19 times, and on the 20th time, I'm going to hand out 2, 4, 8, 6, and I have one card left in my hand, that remainder of 1, that I'm going to hand out to the last person. So the last digit in 2 to the 81st power is going to be 2. Now we're going to do a few more of these. All right, so I'm going to move over here. What about 2 to the 26th and 2 to the 40th? Okay, so we've got our pattern. Step 1 and 2 are done. We have 4 pieces in our pattern, 2, 4, 8, 6. So now we're going to take our exponent, 26, and we're going to divide it by the number of pieces in the pattern. So 4 will go into 26 6 times. That gives me 24. 2, so this is a remainder of 2. So after the 5th time going through the cycle, the 6th time we're going to hand out 2, 4, 8, 6, and I'm going to have 2 cards left in my hand. 2, 4 is the last card that I hand out. 2 to the 40th. Same thing. I'm going to take my exponent, 40, divided by the number of pieces in my pattern, 4. 4 will go into 40 perfectly 10 times. So I have a remainder of 0. So what that tells me is that this pattern is going to fit perfectly into my set of people that I'm handing cards out to. So if it fits perfectly, think about where that's going to land. Everybody gets the same number of cards. So the last person, 2, 4, 8, and I end my pattern on a 6. Okay, so I'm going to highlight here. Here's my 4 number of pieces in the pattern. And my exponent, here's the 81 for this one, the 26 for this one, and the 40 for this one. So let's look at a different set of numbers. Let's look at 3s. So we're going to try this one. What's the last digit of 3 to the 38th? So the first thing we're going to have to do is find our pattern. Okay, so 3 to the first is 3. 3 squared is 9. 3 cubed is 27. 3 to the fourth is 81. Remember, we're looking for that repeater. And 3 to the fifth is 243. So the minute that I see that 3 roll back around, this pattern's going to repeat. So I have 4 pieces in my pattern. There's that second answer that we need. So the third piece in our process is to take our exponent, 38, and divide it by our number of pieces, 4. So 4 will go into 38 9 times. That gets me to 36 with a remainder of 2. So I'm going to go through this process 9 times, 3, 9, 7, 1. And I'm going to have 2 cards left in my hand. I'm going to hand out the 3, and then I'm going to hand out the 9. What if we do 3 to the 21st? So I have my pattern already. I know how many numbers are in my pattern. There are 4. So I'm going to take 21, divide it by that number of pieces in my pattern 4. That will get me to 20 with a remainder of 1. So I'm going to go through this sequence perfectly 5 times. And I'm going to have 1 card left in my hand, and I'm going to hand out a 3. So if you want to go back to your pattern, think of it this way. I have a remainder 1, remainder 2, remainder 3, and instead of having a remainder of 4 that we're not going to have whenever we divide by 4, this is when it fits perfectly. This is our remainder of 0. So our next question is everything going to repeat after 4? And the answer to that is no. What about the last digits of 6 to the 39? So if you go through your 6s, you have 6 and 36 and 216. So all of those are going to end in a 6. The last digits of 5. Now don't think of this as 5, 10, 15, 20. This is 5 times 5 is 25, 25 times 5 is 125, and so on and so forth. So all of our 5s are going to end in a 5. Our 0s work out this way. And then what numbers repeat after 2 places? I know for sure that 4 does, but not everything is going to repeat after 4 pieces. So just set your pattern, figure out how many pieces are in your pattern, and divide the exponent that you are looking for by the number of pieces in that pattern, and that remainder is going to tell you which is the ones digit that you are going to hand out at the very end of your sequence.